Good morning, afternoon, or evening, cats and dogs. I've got another video for you, and this comes from your lesson 3.1 guided notes. So please make sure you have those in front of you as we go to talk through numbers 7 through 22 in those guided notes. This video is going to talk about absolute value plus some other things that deal with integers, like putting them in order, putting them on a number line, and then utilizing or using absolute value in combination with those things. So I want to start, you want to find the box in your guided notes where it says absolute value. I believe it's on the back of the first page. So let's define what absolute value is. Absolute value of a number is the distance the number is from 0 on the number line. So it represents a distance. The absolute value of a number is always greater than or equal to 0. So if I ask you for the absolute value of any number, it should be greater than or equal to 0. Now, it will be a little bit different if you do problems involving absolute value. You could still get a negative solution. We'll see a few of those. Or if you have a negative sign outside of the absolute value bars, you could get a negative solution for your final answer. The symbols, as given right here, I'll highlight these, are what we use for absolute value. They're these double bars. It kind of looks like the number 11 spaced out. Those double bars are used to represent absolute value, and they're treated like grouping symbols in the order of operations. And I know we already mentioned that. So I really like this pictorial, I don't know the word, but this visual of what absolute value looks like on a number line. So the absolute value of 5 is 5 because 5 is 5 units away from 0 on the number line. It's 5 units to the right. The absolute value of -5 is also 5 because -5 is also 5 units away from 0 on the number line. To make it a little simpler, if the number is already positive, it stays positive. If it's negative, it becomes positive. All right, let's do some examples of applying this. So number 7, and feel free to pause the video and try these on your own if you want. Most times students are able to do these without much guidance from me, which is why I chose this for a virtual day. But if you want to do them along with me, that's fine. Or if you want to work ahead and then check them as we go through them, that's fine also. So number 7, we're trying to evaluate this expression. It says absolute value of 10. What is that? Remember, we're thinking the distance 10 is from 0 on the number line. Well, it is in fact 10 units away. Remember, we said as a shortcut, if the number is already positive, we keep it positive. All right, number 8, let's evaluate this. What's the absolute value of -25? Again, we're thinking how many units away from 0 is -25 on the number line? If you were thinking +25, you are correct. Well, we need to make this a little bit more challenging. So number 9, I've got the absolute value of -4 minus absolute value of 2. Absolute value of -4 is 4. Absolute value of 2 is 2. We subtract them. 4 minus 2 is 2. Number 10, absolute value of -6 plus absolute value of -7. Absolute value of -6 is 6. Absolute value of -7 is 7. We add those together. Our solution is 13. All right, moving right along. And again, I would encourage you, feel free to pause the video at any time if you get behind writing down any of this work. Remember also that you should not just be writing down the answer. The work matters too. Number 11, absolute value of -10 minus absolute value of -3. Absolute value of -10 is 10. Absolute value of -3 is 3. We're going to subtract those to get a solution of 7. Now, 12 and 13 go hand in hand. So I've got the negative absolute value of -18. The absolute value of -18 is 18. But I have this negative sign out in front of the absolute value bars. So I still need to tack that on my final answer. So my final answer will actually be -18. So like I said, absolute value itself is never going to be negative. But a problem that involves absolute value and has some other things around it could be negative. So number 13, what do you think the negative absolute value of 10 will be? If you were thinking -10, you're correct. The absolute value of 10 is 10, tack on that negative in front to make it negative 10. All right, let's do some evaluating questions with some algebraic expressions. It says evaluate each of the following expressions if a equals 12, b equals 5, and c equals negative 6. We're going to see a lot of evaluating of expressions, including algebraic expressions this year. So we'll make sure to talk about them multiple times. So the very first thing I do in number 14, it says 16 plus absolute value of c, is I replace c with what it's equal to, which is negative 6. So I do that first. I don't try to do any of the work yet. 16 plus absolute value of negative 6. Now, do absolute value first because remember it is a grouping symbol in the order of operations. Absolute value of negative 6 is 6. We're going to do 16 plus 6 to get our final solution. That will be 22. All right, number 15. Start by substituting A and C into that problem, that expression. Absolute value of A is absolute value of 12, minus absolute value of C is absolute value of negative 6. Now, we've got to do those grouping symbols first. Absolute value of 12 is 12, absolute value of negative 6 is 6, and 12 minus 6 is 6. Number 16, I have absolute value of AB plus absolute value of C. Now remember, AB does not mean we squish A and B together. It means we multiply A and B. So you're going to notice we're going to have absolute value of 12 times 5 plus absolute value of negative 6. So the first thing I did was 12 times 5 inside the brackets, inside those absolute value bars. That got me 60. And then I did absolute value of negative 6 in that same step to get 6. The absolute value of 60 is 60, so I do 60 plus 6 to get my solution, which will be 66. Finally, from this group, absolute value of C is going to be absolute value of negative 6, plus AB is at 12 times 5 again, plus absolute value of negative 10. So I did the absolute values and multiplication at once. Absolute value of negative 6 is 6. 12 times 5 is 60. Absolute value of negative 10 is 10. I added from left to right. 6 plus 60 is 66, plus 10 is 76. You can add all three at once. You can do 60 plus 10 to get 70, add 6 to get 76, whatever works best for you, because addition we can do in any order we want. All right, so pause the video. I have 3 independent practice problems for you to try. I took these from the textbooks. Go ahead and pause the video. Give these 3 a try. Start the video when you're done. All right, how do we do? These also ask us to evaluate each expression. So in number 4, absolute value of negative 9, that is in fact 9. Number 5, absolute value of 18 is 18. Absolute value of negative 10 is 10. I need to subtract those. Final solution will be 8. Number 6, absolute value of negative 11 is 11. Absolute value of negative 6 is 6. 11 minus 6 will get us 5. All right, let's move on to our next topic. So let me find this in our guided notes. Numbers 18 and 19. The directions say graph each of the following sets of integers on the number line provided. Now you don't have these little tick marks on there. I created these ahead of time so that I wouldn't add a lot of extra time to the video. You don't have to have as many as I have, but in number 18, for example, my smallest number is negative 3. My biggest number is 6. So I need to have enough tick marks on my number line to get me from a low of negative 3 to a high of 6. So it's just something to keep in mind. I do try to make them equally spaced. They're pretty close. They're not perfect. But again, you may not need quite as many. I know I have a few extra on here. So I'm going to go ahead. I think the smallest number I have is negative 6. Then I number these tick marks. So I've got negative 6, negative 5, negative 4. They're going to be really squished together there. Negative 3, negative 2, and I wrote these numbers out ahead of time just to save time. Negative 1, 0, 1, 2, 3, 4, 5, and 6. Now again, your number line might have less numbers as long as you go all the way from -3 up to 6. I've had students ask, can I count by twos? Sure, keep in mind that one of your numbers is odd, -3. So I just put every number on here, and sorry about the different sizings of the numbers, but it is what it is. Unfortunately, it's a little harder to type this up on the computer than it is to just write it out on paper. But you might have less numbers, so you really don't need these last 3 tick marks back here. But you do need to have a minimum of -3, maximum of 6. You need to make sure that your numbers are spaced pretty evenly apart. I don't expect it to be perfect. I'm not going to pull out a ruler when I'm grading things or looking at your work, but you want to make them as evenly spaced as possible, since the distance between 0 and 1 is the same as the distance between 1 and 2, and so forth. Now what I need to do is put my dots on the number line. So I need a dot at 0. So I'm going to take this dot and I'm going to slide it down. I'm going to put it right on the number line at 0. You don't need to hover them above the number line. I'm not sure what the obsession with that is, but I see students a lot of times having them hovering up here. I've seen students do all sorts of weird things, like draw arrows to it. Like, what are you doing? Please don't do that. Just put a dot on the number line. As math people, we're pretty simple. You don't need to get too creative. We don't need stars. We don't need fireworks coming out of this thing. Just a dot. We need a dot at -3, so I'll slide one of these guys down, put it there, and we need a dot at 6. So I'm going to slide this guy down and put it right there. And that's it. We don't need anything else. It's just graphing those points in the number line. You might be thinking, this is silly. Why are we doing this, Mrs. Garcia? Well, we're doing this because eventually we're going to graph solution sets for inequalities on the number line. So I want you to get in the habit of, one, being able to put these numbers in order correctly. Notice these negative numbers and how they're placed almost backwards, right? And being able to make the tick marks evenly spaced, knowing where to put dots, and eventually we'll be shading some things on these number lines. All right, let's give number 19 a try. So I need to go from a minimum of -5, a highest value of 4. So I think that is my smallest, was -5. So let me slide these up. We've got -5, -4, -3. I know that's really tight there. -2, -1, 0, 1, 2, 3, 4. Again, I've got some extra numbers on here that you may not have, and that's okay. So I've got 5, 6, and 7 that I don't need. It's okay to have extra numbers. The problem is when you don't have enough. Even though some of these numbers are not in the set, that's fine. I still include them. I just won't put a dot at those numbers. So we need a dot or point at -2. So I'm going to slide this guy down. I'm going to put it at -2. There we go. 1 at -5. Slide that down. Here we go. As close as possible. 1 at -3. It's going to be right here. 1 at +2. So that's going to be right here. And then 1 at 4. So that's going to be right up here. All right. And we are done. All right, we've got a few more questions to take a look at. This is not too long of a video, but we do have a few more. Number 20 is super easy. Number line already given to us. It says name the coordinates of each point graphed on the number line. I created this question because we had a problem like it on the test a few years back, and I didn't have a problem like it in the guided notes, and immediately kids are like, I don't know how to do this, which I think you do. You just maybe haven't seen it before. So we have to name the coordinates for points A, B, C, D, and E. A is at 0. So guess what? A, 0. I didn't put a dash here. Be careful about putting like a little dash like this, because it's going to look like a negative, which 0 can't be negative anyway, but numbers like 2, 3, and 6 can. So I wouldn't put a dash. I'd put a colon there. Letter B is at 2. Easy. C is at 6. D is at 3. And E is at -4. All right, we've got 2 more to take a look at. Number 21. This is one that requires us to write a little bit. Maya is asked to graph the following set of integers on the number line: -3, 2, -1, 4, 3. What did she do wrong? Why would I mark something like this incorrect on a test or a quiz or any other activity that we have? What are your thoughts? Take a moment and think about it. So in years past, I've had a lot of different explanations for this. So here's what I typed in. Yours might not be exactly the same, or your thoughts might be different. And again, you may want to pause the video and jot something down at this point. I wrote, Maya only included the numbers in the set. So she was like, okay, I've got -3, I've got -1, I've got 2, 3, and 4. So I'm going to include those, but nothing else. But there's numbers between those values that are in your set, and you should still include them. The other thing that really makes this incorrect is each of those numbers are spaced evenly. So it says also she spaced each of them evenly. I'm a perfectionist, so I'm going to correct that. Even though there would be a differing amount of space between the integers in the set. So between -3 and -1, that is a distance of 2. Whereas when we look at the difference between 3 and 4, that's a distance of just 1 unit. So they should not be equally spaced. She's also missing dots on this number line. So again, a lot of times students think, well, if I just put only the numbers in the set, I don't need the dots. You do still need the dots, and you need to make sure that your graph itself is numerically accurate. That's really important. Okay, we have one last question in this video. It's number 22. It's called an extra challenge problem because it involves double absolute value, kind of like when we did order of operations and we had brackets and parentheses. We're going to treat it really similarly. It's not a tough problem though, but let's see if we can handle this. So we've got the absolute value of -5 plus 2. So start by finding the absolute value of -5, which is 5. I didn't drop off the absolute value bars that are around the entire problem though, because there's still an operation inside for me to do. So now I need to do 5 plus 2 inside the absolute value bars. That is 7. Then I've got to take the absolute value of 7. What is that? If you were thinking 7, you are absolutely correct. All right, so we've got about 17 minutes into this video. Make sure you have all this stuff jotted down. Maybe make sure you've done the independent practice problems. We will continue to see more practice both on virtual learning days and in class. And don't forget, there are office hours available as well. So if there's things you have questions on, I am here to help you. Thanks for listening.